Welcome back. Today, we're jumping straight into a highly requested, super deep dive explainer on the Metadata API. If you're prepping for your developer certification, or honestly, if you just want to lock down the absolute best practices for massive organization deployments, you're in exactly the right place. We're going to strip away all the fluff and look precisely at the technical mechanics and the exam gotchas you need to succeed.
Here's our roadmap for today. We're going to cover 1. Understanding the Metadata API. 2. Local to production workflow. 3. Creating the manifest file. 4. Retrieve and deploy operations. 5. Programmatic CRUD API calls. And finally, 6. Key limits and exam gotchas. Let's get right into it.
Section 1. Understanding the Metadata API. Core concepts. To ground all this theory, let's look at a fictional case study, Zephyrus Relocation Services. Imagine you're a developer here. The company is expanding like wildfire into Asia and South America, and you need to migrate massive org changes, like entirely new orientation services, across a global footprint. This isn't just updating a single field, right? This is moving complex schema safely and efficiently, and that is exactly where the Metadata API is going to be your best friend.
Now, here is a critical distinction for your exam, and honestly, just for your day-to-day job. The Metadata API never touches business data. No accounts, no leads, no products, none of that. Instead, it moves the schema, the processes, the layouts, and the authorization rules. It's the structural stuff. For example, if process metadata decides what happens when a user clicks save, the Metadata API is what actually moves that rule from your sandbox straight into production.
This brings us to a subtle but totally vital nuance, the difference between a metadata type and a component. Think of the type as the overarching structure, like the concept of a custom object. The component, on the other hand, is the actual instance, like myCustomObject.c. Mixing these up when you're writing your API calls, yeah, that's a guaranteed way to throw a deployment error.
Moving on to Section 2, Local to Production Workflow, the Developer's Lifecycle. Okay, so you absolutely need to follow these exact chronological steps. It's a lifesaver. First, use a retrieve call to bring the production metadata down to your local file system. Second, push those files right into Git to establish a safe baseline. Third, pull that baseline into an empty Scratch org for your active dev work. Fourth, move it over to a sandbox for team integration testing. And finally, deploy the tested customizations back to production. It's the perfect cycle to protect your live data while still letting you iterate fast. Next up, Section 3, Creating the Manifest File, Mapping the Move.
Every single developer needs to have this manifest file structure memorized. It's literally the exact blueprint telling the API what to grab or deploy. So you've got your root package element. Inside that, the types node groups your components together. Then the members tag requires the specific full name of the component you want, right? That myCustomObject.c we talked about. And finally, you have to declare the API version, like 66.0. Missing just one of these nodes will completely derail your deployment.
Oh, and here's a massive exam tip for you. You don't actually have to list every single member by name. You can just toss an asterisk wildcard into the members tag. It tells the API to pull down all components of a supported type. It's a huge time saver when you're building out these files.
All right, Section 4, Retrieve and Deploy Operations, Moving the Files.
You really have to understand the contrast here because it dictates your entire tooling strategy. Source commands are super developer-friendly. Why? Because they track revisions. They know exactly what you changed and when, which makes them perfect for bouncing between a local environment and a Scratch org. But then you have MDPI commands. No source tracking here. They just retrieve and push zipped folders. Admins usually lean on these for those declarative, final stage, file-based moves to production.
Let's dive into Section 5, Programmatic CRUD API calls, bypassing the zip.
This is where things get incredibly powerful. We can actually script our environment updates on the fly. By using programmatic CRUD API calls, your client applications can read, create, or tweak customizations dynamically. You are literally coding the configuration of the org itself without ever messing with a manual deployment file.
So here are your 6 core functions: create, read, update, delete, upsert, and rename. Now pay super close attention to this strict limit. You can only process an array of up to 10 components per call. Try to pass 11 custom objects into create metadata, it's going to fail. The only exception to this rule is for custom metadata and custom application types, which generously give you a limit of up to 200 components per call.
Listen, if you take absolutely nothing else away from this explainer today, memorize this direct contrast for your exam.
Zip file deployments using deploy and retrieve queue up asynchronously. They wait for system resources. But programmed CRUD calls like read metadata or update metadata are strictly synchronous. They fire right then and there, and the code waits for the operation to complete and return a result before it moves on. Do not mix those up.
To actually build out those synchronous CRUD calls, you've got these handy utility functions that basically act as a map of your org. You use describe metadata to see what overarching types even exist. Describe value type lets you zoom way in on the granular fields of a specific type. And list metadata, that gives you a clean list of full names, which you can plug straight into your manifest file or read operations.
And finally, Section 6, Key Limits and Exam Gotchas, the final hurdles. 39 megabytes. That's it. That is the absolute maximum allowed size for a compressed zip folder during a file-based deployment. If your massive Zephyrus migration zip hits 40 megabytes, the API is just going to reject it outright.
And then we have 600 megabytes. Once that initial 39 megabyte zip folder is unpacked on the server side, 600 megabytes is your strict ceiling for all those uncompressed contents.
45,000. I know, it sounds like a massive number, right? But this is the absolute maximum number of metadata instances you're allowed to redeploy at exactly the same time in a single job.
If you push past that 45,000 limit, you're going to get hit with this exact warning scenario. It's a really common trap when moving huge architectures, like our fictional global rollout. When this happens, there's no magic fix. You're basically forced to break your deployment down into smaller, logical batches and split up your package manifest to stay under the limit.
All right, last gotcha, error handling. You always need to account for session expiration in your programmed API calls. Long-running scripts can easily outlive their session tokens. Catching those timeout errors and seamlessly requesting a new session ID is totally crucial. It's an easy step to forget, but honestly, it's exactly the kind of robust design that separates good developers from great ones.
This API is just immensely powerful. It lets you script, scale, and secure the very blueprint of your entire organization. But as we've just seen, it requires intense precision, a really deep understanding of its limits, and strict adherence to workflows. So, considering everything we've covered today, how are you going to architect your next deployment to make it completely bulletproof? Keep that in mind as you study. Thanks for tuning into this explainer, and happy building!